Hello and welcome to our Olympiad stream. My name is Andrei Luchin and I am teacher from Robot Club Helsinki in Finland. And today we are talking about robots and robotics, but in this workshop we will focus on one particular aspect of it. But before we start, I want you to get prepared for our practical assignment. And for that, we are going to use TinkerCAD. If you've never been to this webpage, please get there. And it is www.tinkercad.com. And there you can click Start Tinkering and create a personal account. If you need help with creating an account, you can ask your parents or other adults nearby. And that's what we do after we speak about robots. But what a robot is, people have actually been inventing different devices since ancient times. For example, Leonardo da Vinci invented a mechanical knight armor, which could move its arms, neck, sit down, and even open the mouth. So it was a functional device, and a copy of it is in the Milan Museum. One more device from times, and that was in 18th century. It is the scribe, an automatic figure of a boy. It contains about 4,000 parts, 4,000 different pieces, and it is able to write any text of 40 characters independently dipping the pen into the inkwell. Looks great, isn't it? So, but then we get to modern times, and there are many different robots nowadays, and maybe some of them you know, but not all of them are actually robots. Please think of which of these things are robots and try to identify them, and write your answers in chat. Which of these are robots and what picture does not show us a robot? So while you're writing, we will continue with the definition though. So the devices around us are mechanical, automatic, or robotic, but how are they different? And what makes a robot a real robot? So mechanism is a device with which a person performs physical work, or it can be a moving part of a more complex device. But the simplest ones are a lever or a wheel, for example. Then an automaton is a more complex thing. It is a device that can operate according to the program included in it. Everyone knows a mechanical clock, and it is a good example of an automaton. And then we get to the robots. A robot is an automaton also that can navigate in the environment. It can also make somewhat independent decisions because of the artificial intelligence and because of the information it gets from the world around that helps it to make its decisions. All right, we are back to this slide, and let us read what you've written. Any ideas? So for sure, not all of them are robots. And as we discussed earlier, clock is an automaton. What about this mechanical duck? Would you call it a robot? Or actually, it is quite a simple toy, and it is not real robot. It is a mechanism that does certain function. All right, a vacuum cleaner robot. Yeah, it claims that it is a robot, and it really is. It has sensors to navigate around your house, and it can do its job quite independently. And that's what's important for robot. How about these guys? Are these the robots we were looking for? Great. Okay, let's read some answers. The gray flat one and Star Wars. All right, I think it was about the vacuum cleaner robot. And robots from Star Wars. Well, it's a tricky question. They are and they are not, because in the film, they are robots. But, well, while filming, they are human actors, just using costumes. So, thank you for your answers, and let's move on. The next thing we are talking about is, what do all these things have in common? How are they similar? So here we have a light bulb, a vacuum cleaner, a robot, a plane, a laptop or notebook, depending on how you call it, and a smartphone. Please give your ideas. What makes them quite similar in how we use them? Any ideas? Well, they are all modern devices, well, quite modern, some of them older, some of them newer, but the idea is that all of them use electricity to function. And that's what makes them that similar. But if you ask what electricity is, well, we use it in everywhere in the modern world, but what it is, not everybody knows really, and we have the answer. It is quite simple one. They are very, very, very small particles that travel through wires at high speed. And these particles, they give us that energy. And today we are going to focus more on electricity and circuits, electronics, circuit designs. So what circuit engineering does, it works with all kind of circuits that we use in different devices. It is a scientific and technical field that deals with designing them, creating them, debugging them, and all kinds of electronic circuits. They contain smaller parts that are electronic components. And if you want to know how to manage them, you need to study circuit engineering. And today we are going to get familiar with the very basics. And there is a large theoretical base behind it, but we will do a few simple experiments. So circuit engineering studies principles and how they electronic components or parts are interconnected and what special parts are used. To begin with, we are going to try quite a simple circuit. We are going to take a light bulb and a power source, or well, it's going to be a battery, a power supply for our circuit. And we are going to use a couple of wires for that. So if you happen to not have a bulb and a battery nearby, we have TinkerCAD to help us. And it's time to get to TinkerCAD now. Hopefully you have an account and it is ready for working. So we are in TinkerCAD, and once you get there, here on the left, you can click Circuits. And there is a green button, Create a new circuit. You can click it immediately, and you get in the environment that we are going to use today. So, hope you are in there, and let us build the first simple circuit. So here we are not going to use a light bulb, but an LED. It is basically the same. So you can find it here on the right. Click it and then drag and drop it to the center of the screen, the working area for all of the builds we are doing. So we are going to take an LED and a power source. For an LED, it is enough to have a smaller battery. So we'll just take a coin cell, 3 volts coin cell. And we are going to connect them. But how do we do that? We need to check what are the contacts on the cell and on an LED we have. So here we have a straight leg or cathode, which is essentially a negative contact or a minus sign, if we call it that. So we take a wire from here, click in this leg of an LED, and put it to the negative contact of our coin battery. You can move it around to see the wires better. They are not going to disconnect. They are going to move around with the whole construction. So it's fine if you want to replace it somewhere else. Then an anode is the positive or plus contact of an LED, and we put it to the positive or plus contact of our coin battery. And it is basically it. Our first simple circuit is done, and to make it work, just get to the right top corner of the interface, and here we have this Start Simulation button. Click it, and it turns immediately on. The LED lights up, and the circuit is working. You can start and stop simulation as many times as you like, and you can even move it around a little bit while it is working. And so we covered the basics of how we work here in TinkerCAD circuits, but that was only the beginning. we are going to try a way more complex automated circuit. So back to discussing what parts we use for that. And first of all, we are going to use an Arduino UNO board. It will help us study the circuitry. It is used for creating simple and not very simple automation and robotics system. And you can connect different sensors and motors and screens to it and program them, even program them. With this board, you can do everything from flashing lights to 3D holograms and even robots controlled from your smartphone. Let us look closer at what we have here. The basic components are the microcontroller. So it is the brain for the board, and all the programs and all the actions are processed there. Number 2 is board for connecting it to a computer. So it's through USB. Then the third one is power connection port. If you want to have a separate power supply, for example, a battery box for your Arduino, then you are going to use that connection. And then we have all the different pins for connecting external devices. And we are going to have a closer look at these pins because we are going to use them right away. On top of Arduino board, there are control pins. They are digital pins. And they are actually used to give signals to external devices we connect. Then here on the left, we have power pins or direct current pins. And for example, here we have 5 volts pin. It is kind of a plus on the battery. It gives us energy constantly. Then we have ground pin, and it stands for minus or negative contact. And then we have analog input pins. We are going to use them to get information from external sensors in our system. And the thing we are going to try out is a simulation of a musical instrument called the theremin box. It is made of electronic components, and it allows us to change pitch of the sound in non-contact way, more or less blocking the photoresistor from light. And the original instrument was invented in 1920 by Lev Theremin. And now we have the opportunity to reproduce it using an Arduino board. So here is the circuit diagram of the theremin box, and such schemes are used usually to show what parts or electronic components we need to use. And we are going to check which ones we are going to use. First of all, we need a piezo buzzer. It is a small speaker that translates electrical signals to sound. And as we are talking about musical instrument, that's what we are going to use for sure. Then a photoresistor. It is also known as light-dependent resistor, and it decreases resistance depending on light around it, thanks to its light-sensitive surface. And we are going to use a bunch of wires to connect all the components. Let us have a closer look at the scheme. Here we have this piezo buzzer. So its negative contact is connected to the ground pin of Arduino, and its plus pin is connected to digital pin number 3. Then we have a photoresistor. It also needs 2 connections to A0 analog pin and to the ground or negative contact for our circuit. And we're going to add one more resistor that will help us to set the components and adjust the signal. It's time for experiments. Get back to TinkerCAD, please. And let us create the circuit. The components we are going to use can also be found here on the right. And as we discussed which of them are needed, you can just drag and drop them to the working field. We will find use for them a little bit later. So a piezo buzzer, a photoresistor, and an Arduino board. Yeah, it was the first one we covered actually. And a resistor. So we could have connected them all with simple wires, but if we are talking about creating a real life model, it is not going to be that simple. So for that, we are going to add one more part, which is a breadboard. So here is how it would look if we create it with our own hands in a real world. So there is a whole lot of wires used. And to connect them all, we are going to use breadboard. So let's begin with placing the components first. So a buzzer. Just make sure that the contacts get in the holes on the breadboard. Then we are going to place a photoresistor down here. And a resistor. It's going to be close to the photoresistor here, but we need to rotate it a little bit. And in the top left corner, there is a rotation button. Please click it a few times so that our resistor is in the horizontal view. And we place it just a little bit below the photoresistor so that the contacts are on the same line. So if you use your mouse to you can place it over the breadboard, and it shows that all the pins are in contact, all of them with the 15th mark here. So the parts are on their places, ready to go, but then we need to connect them all. And as we checked on the electrical scheme earlier, we need to connect 5 volts from our power source to our plus line on the breadboard. And we need to connect negative or minus contact to our minus contact on the breadboard. Then we are going to use different Arduino board pins for connecting other components. And as we need signal that is going to go from phototransistor to Arduino, because analog pins are input pins, the signal is going right from pin 15 here on the breadboard and goes to a 0 analog pin in Arduino. And for our piezo buzzer, that is going to take signals from Arduino board, we connect its plus contact to digital pin 3. And what we have left to do is adding a few more wires to connect our components to negative line for piezo buzzer. So it can get here, for example, and negative contact for our photoresistor. So you can just connect it close nearby, but to our negative line down here on the board. And what's more, we need plus connection for our standard resistor. And the circuit is basically ready. You can try and start simulation and check if anything happens. And it seems that nothing does. But why is it? Well, the Arduino board does not know what to do yet because we did not use any program for that. So it needs to be pre-programmed, and for that we get to code. So once you open it, you have a few blocks here already, but we are not going to use them. You can drag and drop them all to the trash bin. We are going to create our own program. And let us think of how we do it. So we actually need to give signal to the piezo buzzer. So this third pin is going to be our output pin. And for that, we take this set pin 3, and we have a variable here, but we are going to replace it a few seconds later with other numbers, because we are going to actually get an input signal to our Arduino board, and it's going to be our analog pin 0. You can try and place it there just like that and check if it works. and it does work. But now it is all about experimenting and adjusting numbers. And if you start simulation and click this photoresistor, here is the light level, and you can adjust it to change the sound. Make sure that you have sound on your computer on, otherwise you are not going to hear this buzzer. And try to start simulation and change this slider a little bit, move it left and right. So here it stands for dark or no light. And here on the right, we have bigger light level. We can change sound a little bit more if we add some math blocks here. So that's why we can change the range at which we actually work. And so we are going to use this very first block, and we are going to change this sign to dividing it. Then we are going to divide the input values we get to our pin by, for example, let us say 10. And you can put this back to the block we originally used. If you start simulation now and use the slider again, you are going to have slightly different sound pitch. And we can even more change it, because these values can be adjusted from, let's say, 10 to up to 80, maybe. And you can check now. So feel free to do your experiments with changing the values and check how it works. Well, another value you could possibly change is our standard resistor we are using here. You can add some values here, because actually the range we can use here is not unlimited. It only takes a few grades or steps of signal, but using this resistance value of our resistor, you can change it further, and you are going to get different sounds. So that's an extra task, adjusting the resistor. What if we change 10 kilo ohm resistor with a resistor of 100 kilo ohm? You can try that too. And that's how it works. In real life, we do not have such a slider, but we would just use our palm, for example, to cover the light sensor, the photoresistor we have here, to change the sound. Or we are going to use a flashlight to add more luminosity, and then it is going to give us different sound again. You can even find videos. Well, if you just look for them on YouTube, for example, that people use this quite simple and at the same time quite advanced, because it includes circuits and electrical components, musical instrument for producing some music or playing it actually. And that's a great example how circuit designs and different circuits let us create automated systems that get information from the environment, like light level in our case, and they give us back another signal, which is sound. And it is used in robotics, well, basically everywhere. So robots use light sensors, they use other sensors. Well, we already had a few examples on our previous workshop. And they really use many sensors and many circuits. And if you want to be successful as an expert in robotics, you need to know how the internals, the electrical parts and components of robots work, how they interact, how to connect them, and how to make them work together, resulting in an effective and functional system. That's all for now. Hope that was good experience and you learned something new and interesting. And good luck with your future studies on the field of robotics. Thank you for your attention. Have a nice day. Goodbye.